Hi folks, welcome back to Physics with Captain Ron. I'm making this video here to help you out with numbers 20, 21, and 22 in your Unit 1 homework. So let's see, below, the graph represents the motion of an object. Comment on the direction of motion, whether speed's increasing, decreasing, or constant. So this is a conceptual thing. It's important to realize, right, what type of graph am I looking at here? This is x in meters. That makes this a position graph. All right, and now, how does your velocity relate to that? So remember, velocity is delta x over delta t. This gives the what's called the average velocity. That's why I put that bar over it. And that is slope of a position versus time graph. So just keep that in mind as we go through these questions. So the first one, describe the motion of the object during the first 4 seconds. So that's talking about this stuff. So what I'm getting at here is I want you to say, all right, here's where the object is, and you should be able to actually get a number, and then decide whether it's moving or not. And if it is, give a right or a left. Okay, 5 to 8, that's this region here, I believe. 1, 2, 3, 4, 5, yep, 6, 7, 8. So what I'm looking for here when it says describe, I'm looking for, it's starting here and then moves, give a direction, right or left, and do so assuming right positive. And if you can give a speed, do so. And you should be able to do a speed here, because remember, your velocity is slope of position. 13 to 17, where is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, that's talking about this stuff right here. So you comment on it's starting here, ending there. You should be getting numbers for those. And it's moving right or left. You should be able to decide based on the slope, and you should be able to give a speed. And just write those things out. Write a couple, 3 sentences that describes that. So when I say describe, that's what I'm talking about. No real math required. All right, 21 is kind of a conceptual one here too. Let's see, the picture represents 3 different situations. The delta t's are all the same. So again, imagine these are snapshots in time. Now as I look at these 3 different situations, notice for the first car here, the delta x's, these distances are not significantly changing. I'm attaching the word significant because I probably put them there by hand. I didn't get a ruler out, but there's really no significant change in that displacement. That should tell you what the slope of this should look like, basically. Here, you'll notice the delta x's are getting bigger. So make sure when you graph this that your graph shows that accordingly. And then this case right here, the delta x's are getting smaller. So again, make sure that your graph shows that accordingly. So I'm looking for sketches here is what I'm looking for, just rough sketches. All right, 22. Let's see, the graph represents the position of an object. Answer the questions, give support. So 22, was the object moving at 2 seconds? 2 seconds on the graph is right there. So ask yourself, moving or not? And when it says give support, state some sort of reason. The slope is the following. That's what that would look like. Same type of thing for 6 seconds. Is it moving? Yes or no? Yeah, all of these are the same types of questions. Just make sure you give support for your answers. I'm not going to take them when I look at them if you don't give some sort of support. And that support is basically centered around, is the slope positive, negative, or 0? Or the other way you could answer that is the x value changing at that time? So either one, just make sure you address it in some way, shape, or form. I'm going to call that video good. Have a great day.